Okay, we have here today this interesting property of the definite integral. We've got, if we have this condition here, if f of 2a minus x equals f of x, then we can use this property where we're basically taking this integral, we can cut the upper bound in half. The lower bound's 0, so we cut the upper bound in half, but we bring a 2 out front. So I don't want to say you can always use this. It has kind of like a limited use, particularly with trig integrals. I think a lot of times with even functions, you can kind of notice the similarity here to the property of the even function, where when you have symmetric bounds, then you end up with this situation where you have 0 for the lower bound and you bring a 2 out. And it's not a coincidence where your trig functions are periodic, and usually if you just shift them, it can be used like an even function. So there's a lot going on there. But really what I want to do is show how this works and why this is true going from here to here. So what we'll do, we'll start off from this point, and I'll just rewrite this. So using this as our starting point, we'll just take this, and what I want to do first is just break up the bounds. So first I'll write this integral going from 0 to a dx, and then the rest of it, we need to cover the rest of the bounds, so we'll actually start at a and go to 2a of the same integrand. And here at this point, we already have part of what we want to show. This is the same as this. And what I want to do is just want to take a look at this second integral here, just looking at it from a to 2a. And what I'm going to do on this is we'll make a substitution, and I want to use this 2a minus x value. So what I'm going to do for my substitution here, I'm going to say x equals 2a minus u. So then our function is going to be f of 2a minus u, which is just like this. So then for our dx value, this is going to be the same as minus du. We'll go ahead, we'll make this substitution. So if I take a 2a and plug it in here, my upper bound is going to be just 0. We plug in an a, 2a minus a, I get an a for the lower bound. Then again, our function plugging in for x, this is going to become 2a minus u. We'll have our minus du here. Now I'm just going to take this minus sign here, and we'll use that to flip our bounds. So this is going to go right back so that we're going from 0 to a now. But with this being a definite integral, I can rewrite this in terms of x if I want, because that's not going to change anything. So we'll write this as f of 2a minus x dx. But now notice we have our f of 2a minus x here, we have f of 2a minus x here. We've already assumed, we're already making this assumption that we've done this check that f of 2a minus x is equal to f of x. So I can actually write this here as f of x. So now rewriting this down here, we're going from 0 to a, and now I can write this as f of x dx. But now again, we're working on just this piece here, so I can take this and put this back and continue from there. Okay, now I've plugged in the integral from the previous board, and the thing we notice is just that these two are exactly the same. So I can actually just combine these together and write it as two copies from 0 to a of f of x dx. And that's exactly what we wanted to show right here. Think about, so we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.